working away through finding volumes of revolution. And we got two here, where we're going to have the area between two curves rotated about the x-axis. And remember that the formula looks kind of like the one we had, pi f of x squared, but now it's pi, big guy, red one, take away little guy. By the way, that's green, although it looks blue on my camera. So I have somewhere under here the first one. Here we go. A lot of the process is going to look very similar. A lot of the trick to making this work is process. You know, if you set it up the right way, you normally don't go too far wrong. So I would probably be putting this guy in Desmos right now, but let's see if we can do it without that. Can you imagine that that is what 9 minus x squared looks like? Y equals 5 would be a straight line, something like this. And we are taking, oh, I made a mistake. I'm glad I noticed this. There are only 2 lines mentioned. And so the area that they're interested in is that area. Are we comfortable that if you've given 2 curves, the area between them in this case is that one? Right, so that would be your first step. Draw what you're looking at. Now you're going to be rotating about the x-axis. And I'm mumbling myself looking for a color. Right. This guy here and this guy here, if I draw one of those little rectangle things, see them? This guy here, this guy here. This top one is F, right? And this bottom one, whatever it happens to be, is G. Can you see in this case, the F is 9 minus x squared and the G is just 5. Y equals 5 counts as a curve, right? Counts as a function at least. So the volume of this shape, when you rotate it, is going to be the integral from this number here to this number here. Now in Desmos, I'd be able to read that off, but can you trust me, it's -3 and 3. So it's from -3 to 3 pi f of x squared, take away g of x squared dx. A little bit messier because there's a little bit more going on in this question. If you take f of x, which happens to be 9 minus x squared, take away the other one, which just happens to be 5. So 5 squared is 25. We're looking at that. So far, so good. F of x squared, the straight line y equals 5, which is what g of x is being, 25. Okay, what do I do next? I mean, that's not really in a form that's going to be able to integrate easily. So what do I do next?
FOIL the 9 minus x squared.
Okay, so that's going to get me 81, take away that guy, plus that guy, take away 25. Are you happy with that? That's what you get when you FOIL this. Combine the numbers, I think it's worthwhile. So let's just do it. I got 81, take away 25, and I got 56. And I think by the time we get to there, can I do my ... now? Wouldn't that just be a big power roll with some ridiculously ugly number? Wouldn't even want to guess what it is. But won't it be a positive number? Now, I'm going to try. I'm pretty sure I'm going to be a failure at this, but I'm going to try. If you took this shape and you rotated it about the x-axis, wouldn't there be a cylindrical hole in the middle of the shape caused by that horizontal line? And then above it and below it, something that looked like that, going all the way around. Not that I ever use them, but I have seen them. We've probably got some. Isn't it a bit like a napkin ring? Not to visualize it. So far, so good. Any questions about that?
Where's the pi coming from here?
The pi has always been in the formula. It's from here. All volumes of revolution have a pi in them. The pi comes from the way that you create the shape by, because it's a kind of circular motion, pi gets involved, like the area of a circle is pi r squared. That's kind of, I was looking at the screen there to see if I could see a better version of that, but I can't. So have fun, try to figure out what that looks like in 3D. I can imagine it, just can't draw it. So our next guy, because there's only two of them, is question 11. And question 11 has y equals x to the 5, at least in my version, and square root of x, and it's going to be rotated about the x-axis. So the first thing I do is I say draw this guy, and I'm going to draw him wrong. Well, not wrong. Wrong. You got this guy. I'm going to draw it badly. I bet that's the word I think I'm trying to use. Can you pretend that's x to the 5? It's not a great version of it. Okay, I've kind of lost my screen here. Here we go. And won't the square root of x look like that? And so the guy that we're going to rotate about the x-axis is that little piece that looks a bit like an eye. I need to find that number. Desmos would tell me that guy. I know we don't have Desmos in front of us, but you should be able to tell me what the x coordinate of that point is. Look at the two equations. Where did they intersect? Obviously 0, but what about the other one?
One.
Yeah, one. Wasn't meant to be a trick question. I mean, I guess if you were stuck, wouldn't you be trying to solve that if you wanted to do it algebraically? I mean, it's not hard to do. So the integral is going to be from 0 to 1. It's going to be pi. There's going to be a guy called f of x, which will square. Take away another guy called g of x, which will square. Do a dx. So you have only one decision to do now, and you're pretty much got this question set up. Red guy or black guy? Which one of those two is going to be my f of x?
Root of x.
Correct. So if you imagine one of those little vertical lines, they're always at right angles to the axis of rotation. Can you see that guy there, top, and that guy there, the bottom? You see the red guy is F and the bottom guy is G. So there's my F, there's my G. So it's going to be the square root of x squared, take away x to the 5 squared. And I'll do my dot, dot, dot now. Would you agree that's a power rule? Won't be too hard to do. I think it's 9/20, but don't quote me on it. So if you want to rotate a shape that is the area between two curves, and it's to be about the x-axis, the formula is basically the one that's furthest away from the axis squared, take away the one that's closer. And once you get to this step, your question's pretty much over. The rest is pretty straightforward. Well, that is area between two curves rotated about the x-axis. Let's do the area between two curves rotated about the y-axis. So here's our guy. I love this guy called x equals f of y. I have another one, the green one, I'm going to call him x equals g of y. It's going to be from C to D. So whatever this region here happens to be is going to be rotated about the y-axis. So there must be a formula for that situation, right? There's been a formula for every other situation. Well, let's look at the formula when it's rotated about the x-axis and see if that might give us a clue to what the formula would look like when it's rotated about the y-axis. Okay, anybody want to have a shot at it?
Volume equals integral from a to b of pi times f of y squared minus g of y squared.
Yeah.
In terms of y.
Yeah. Would you agree it's essentially the same formula, but just y's? Which isn't a surprise, really, isn't it? Isn't it just an orientation issue? You know, which direction you're going to do things. The math doesn't really, well, it doesn't really confuse the math much. So that's going to be the formula that we're going to use for questions 9 and 12, because there's two of them. So my version of 9, and then we'll do my version of 12. And question 9 has got a kicker in it. And I didn't realize it until I looked at it this morning. This shape, this area between these two curves, is going to be rotated about the y-axis. But when you look at the information, isn't the information given to you in the form that we usually expect it to be if it was being rotated about the x-axis? That's how we would normally write it for an x-axis, right? Everything in an x-axis. I'm still going to draw it. And then I'm going to have to adapt. If you do y equals x squared, basically it looks like that, right? If you do y equals 4x, it ends up being that guy. And so I can see the area that's to be rotated, but now it's going to be rotated about the y-axis, which means we have an issue. shouldn't these guys be written that way, as x is a function of y? So here's my volume. I know that guy there is 0. And this point here is 4. So I know the integral is going to be from 0, y equals 0 to y equals 4. It's going to be pi. It's going to be a guy called f of y squared. Take another guy called g of y squared dy. Okay, if y equals x squared, what is x?
Square root of y.
And if y equals 4x, what is x?
Y over 4.
Are you all comfortable about what we had to do here? Now we have an extra problem, but it's a problem that's always there. Red guy or green guy? Which one of them is going to be my f of y?
The red one?
Yes. The one that's furthest away, right, from the y-axis. The one that's furthest to the right is f. And the one that's closer is the g. So what we have here is the integral from 0 to 4. F of y, which is this fella, but he's written like that. So it's the square root of y squared. Take away the straight line, which is 1/4 y squared dy. That becomes pi. The integral from 0 to 4 of y. Take away 1/16 y to the 4. At this point here, would you agree the hard part's over with? Any questions about that? Are you comfortable with the fact that because you're rotating about the y-axis, the equations have to be rewritten in a form that is compatible with that direction? In other words, has to be in y's, right? If you rotate about y-axis, your information has to be about y's. Doesn't your start and finish have to be in terms of y? Everything's in y's. Are we good? Okay. There's one more of these guys, and that's basically the only two shots that you get at it. But as I said, the homework questions always have variations in the numbers, so you can still get practice at it. Hopefully, that is enough. And this fella is a little bit more standard. The equations are written in the way I would expect them to be written. And I'm going to do this one using Desmos. So let's see what these two guys look like when you do Desmos. So the first one was 2 take away y squared. Forgot my x's. There we go. In my second one, it's going to be x equals y to the 4. There we go. I'll zoom in on this a little bit. There, can you see it? Looks like a squashed egg, I guess. We comfortable with that? Now, what I need to know that guy, and the answer is 1, and that guy, the answer is -1. So I'm drawing a poor version of that same guy. We'll see it in a minute. Almost done. Okay. Should be ready to switch over. So I've basically just did another copy of that. Doesn't need to be particularly detailed, but it was essentially that blob, right, between here and here. So I should be able to get everything I need out of this poorly drawn picture. The volume of this shape being rotated about the y-axis is the integral from -1 to +1 pi, a guy called f of y squared, and another guy called g of y squared dy. It's going to be pi, the integral from -1 to 1. Okay, you only got one decision here. Red guy or blue guy? Who is f of y?
Red guy.
Red.
You all comfortable now? I know you only seen a couple, but is it kind of obvious how you know first f and second g? So this is going to be 2 take away y squared squared, subtract y to the 4 squared dy. If you FOIL this out, you get 4 take away 4y squared plus a y to the 4 take away y to the 8. And at this point here, can I just do the dot, dot, dot again? I think almost exclusively the functions that we end up integrating, weren't they pretty standard? A lot of them were polynomials, but even the ones that weren't were, you know, e to the 2x or something. There wasn't anything extremely difficult to integrate. So really, typically, if you can have this thing set up correctly so you can transfer your information, you're pretty much good to go. Any questions about rotating about the y-axis then? Last chance? Okay. Now, area, this is number 5, almost there. 5, the area between two curves we've done that, but here's the change. Rotated about a line parallel to the x-axis. This is like the ultimate version of awkward. So if it wasn't bad enough that it's the area between two curves, we've now added in one extra level of complexity where we're no longer going to rotate about the axis, the x-axis at all. So I already know that that's in the wrong spot. That should be in 13. Let's show you what that looks like. Okay, let's have a function y equals f of x, nothing wrong with that. Let's have another function y equals g of x. Lots of colors here. Let's have that as a, and let's have this guy as b. And the region that's going to be rotated is that region. Looks a bit like a fish, or a fish without its head. Now, we normally rotate about the x-axis, but now we're going to rotate about a line that's parallel to the x-axis. And there's two versions of this. There's the line that's below, which is where this pen is, and I'll show you that as well. there's a line above. And they do change what the formula looks like. So let's have a guy here. But I'm going to put a number in him because there are just too many variables here. So let's suppose this is y equals -3. Right? So if you rotate this shape about that line, can you imagine what you would get? You would get a very funny looking napkin ring with a curved hole in the middle, and it'd be a lot fatter than it would have been if you rotated it about the x-axis. Agreed? It's further away. Now the formula takes on a look that's not that clean. V, the integral from a to b, it's pi. But it's not f of x squared take away g of x squared. In this question, I had to introduce a number that is added onto the function. You will also see this formula written more cryptically, something like this. Now you won't see the formula written this cryptic way often, although I have seen it. This one is really only specific to the line y equals -3. If this line was y equals -2, this would become +2, and this one would become +2, and so on. So the 3 is only because of that line. I prefer big radius take away small radius. So we need to figure out, I guess, first, where does this formula come from? And then more importantly, how we can use it. Well, I'm going to start by putting one of those little rectangles that we put a lot in. Remember this one? And the distance from the axis of rotation to the first curve, that's the small radius. Let's see how that works. Would you agree that the distance from here to here is the value of the function, and the distance from here to here is 3, so the value of the function add 3. So that's where that came from. What I call the small radius. Right. Now, the big radius is from there to there. That's big radius. And let's see what that distance is. Well, if you start at x, that distance is just the value of the function, and they're going down is 3, so the value of the function is add 3. So it's an adaptation of the f of x squared take away g of x squared. But do you see in this context here that you need to add an extra number because it's being rotated a bit further than the x-axis? It's being rotated 3 more. Does that help? Right. So let's find a question that does this version, and then I'll show you one at the top. And so I'm on the hunt now for questions that rotate about the x-axis. Okay, that 14 is good, but it's the other way around. So let's see if 15 does better. No, I need one with a negative. Come on. Gotcha. Okay. So the question that we're going to use to represent this situation is question 16. And the function we have is 7 cosine x. Seven sine x. We're going to do it from 0 to pi upon 4, and it's going to be rotated about the line y equals -1. Like every question that we've done, I start with the picture. Now, if you do 7 sine x, it goes like that, and then it continues. And if you do 7 cosine x, it kind of goes like this, and then it continues. If you do x is 0 and pi upon 4, you get there, and you get there. So the region that we are going to be rotating is that guy. Are you comfortable with that axe head shape based on this information? Then we are not going to rotate it about the x-axis. We are going to rotate it about that guy. And I'm going to make no attempt to draw what that thing looks like. But most of these things just look like napkin rings to me. Right, so we should be able to set up the integral that does that volume. Well, it's going to be the integral from start to finish, so that was the easy bit. Pi is there. One of these guys is basically going to go here, and the other one of these guys is going to go here. Right? Do you want me to do this question as a big radius square take away a small radius square, or do you want me to do this question more like this? And both get you the same answer, it's just how your brain understands what's going on. Have you any preference? Okay, pick one then. Don't care which.
Big radius, small radius.
Okay. So I'm going to do my little baby vertical rectangle. And this distance here, we'll call that SR for small radius. And this distance from here up to here is going to be our big radius. Okay. So it's going to be the big radius, which is the longer of the two squared, subtract the small radius, which is the shorter of the two distances squared. Okay, small radius, distance from here to here. Would you agree that this bit is 1 plus the height of the black curve? And the black curve, by the way, is 7 sine x. So the small radius, that distance from here to here, is 7 sine x plus 1. Now, what's going to happen with the big radius, the green one? Well, maybe you could tell me. Oh God, things are really out of script, but pretend they're in the same line. What's the distance for this axis to the top of the green? From there to there. What is it? What's the big radius going to be?
Is it 7 cosine x plus 1?
Have you noticed that these two guys tend to look the same? Right? It's basically function add 1. Now, the next bit is really messy because I'm going to take this and FOIL it. So when you FOIL 7 cosine x plus 1, you get 49 cos squared x's plus 14 cosine x's plus 1. Take away, when you FOIL this guy, you get 49 sine squared x's plus 14 sine x's plus 1. And when you break about or break apart, whatever you want to call it is, you get 49 cos squared x's. Take away 49 sine squared x's plus 14 cosine x's. Take away 14 sine x's, and at least the ones cancel out. And we are left with a major problem. I'm just rewriting this guy up here because it's a bit crushed. We have to find some way to integrate this expression. And it's no trivial matter. It's not easy. Okay, let's talk about the easy parts first. I know how to integrate that, so I'm just going to write it down because I know how to do it. I know how to integrate 14 sine x, so I'm just writing that down. What I'm having a problem with is that guy.
Could you start by factoring out either 49 or factoring out 7 from the entire expression?
I like your 49 trick, so I will do that because that is a good start. So one of the strategies you should do on a really ugly question is to see if there's anything like factors you can take out. Would you agree cos squared x minus sine squared x is a little bit easier to deal with than having 49? Now the hardest part, somewhere in your brain, you did 142. And in 142, of the many things that you saw, you once, at least once, saw cos squared minus sine squared x being turned into something else. Can anybody remember what cos squared? If it had a plus there, it would be 1. So you're darn close. But it's not. It's got a negative, so it's not 1. Or -1 for that matter. And I could just tell you, but then you won't remember it. Because obviously you were told it last time and you've forgotten.
Isn't it cosine of 2x, I want to say?
It is.
Yeah.
You are right. Now that means that we're now at this stage here, right? I think I should take this one a little bit further. If you integrate the cosine of 2x, can you trust me that eventually you get a half the sine of 2x? You could do that as a substitution. Couldn't you just make u equal 2x and do it that way, or linear shortcut method? If you integrate 14 cosines, you get positive 14 sines. And if you integrate negative 14, for some reason, that turned into pi. There we go. If you integrate negative 14 sine x's, what do you get?
Positive 14 cosine x.
Agreed. And at this point, I'll do my ... But couldn't you just plug in pi upon 4, get the exact value, plug in 0, get the exact value, and hopefully something nice comes out of it. Are we good so far? I mean, we are getting to the end of this section, so you should expect things to get harder and harder, like more complex at least. So let's look at our last one. At least we can set it up and we'll finish it tomorrow. We're going to look at the area between two curves, rotated about a line parallel to the y-axis. It's essentially the other orientation of this guy, right? So let's see if I can set up a general question. So what we're going to have is a function x equals f of y. We have another function x equals g of y. We're going to be starting at some point, call it C, just here. Going to finish at some point, call it D. Just here. The area that's going to be rotated then is the area between the two curves. And we are going to be rotating this fella on an axis that's parallel to the y-axis. And maybe it will be something like x equals -4. Now, if you want to get the volume of this ship, it's the integral from C to D. It's going to be pi f of y plus 4 whole squared. Take away g of y plus 4 dy. Are you comfortable about this formula and that formula and how the transfer looks? If I did it in terms of big radius, take away small radius, wouldn't I just be putting a dy here? Now, if you want to think about what does that radius look like, if you do one of these little rectangles, isn't the distance from the axis of rotation to the first one the small radius? And the distance from the axis rotation to here, that would be the big radius. What do you think would happen to your answer if you got these two guys switched around? In other words, the big and the small became the small and the big. What do you think would be noticeable about your answer if you did that?
Negative.
And do you know it would be negative the right number? So if you got -3/4 pi, wouldn't the answer just be +3/4 pi? Which means it's quite easy to fix, isn't it? So you imagine if you're in a test and you got the answer -3/4 pi, you could probably say, oops, got them wrong way round. And you would just put on the next line, v equals 3/4 pi in brackets, switch the two around. And that would be enough for you to do it. So you don't have to rewrite the entire question. Now, what would happen, and I forgot to do it on this one here, but what would happen if the axis rotation was on the other side? Let's suppose at x equals 10. Well, can you see that everybody changes places? Do you see the red curve is going to be the small one and the green curve is going to be the biggest? And secondly, this distance, the small radius and the big radius, have quite different look to them. If you rotate on an axis to the right, this one here, the small radius will actually be 10 take away f of y, and the big radius will be 10 take away g of y. So it's not the function add the distance, it's the distance take away the value of the function. Okay, and the same thing's true if I did one up here, like at y equals 10. This would be 10 take away f of x and 10 take away the other guy, g of x. Okay, last name, that's all I need. Don't need the last name, first name. It's easier. I found it's easier if I just have one name to start under. So last name, and that's it. Bye-bye. I'll hang about for a few moments if you have questions. But tomorrow we're going to finish off Volumes of Revolution. And talk about
What are we
test.
supposed to put in the chat? I'm so sorry. I had somebody.
Your
else talk
last
to me.
name.
Thank you.
Your
I'm,
last name. So in my case, I would just put Robertson. And Maggie would put Breesley, for instance.
awesome. Thank you. I'm so sorry about that.
Not a problem, Stefan. Right, what have we got, guys? Any questions? Because I'm out of here if there's not.
Professor, I have a question on the problem 16.
Uh-huh.
Isn't it 49 over 2 sine 2x? I mean, the last part.
This here should be a plus.
After that part, after we get the 1 over 2 sine 2x.
1 over 2 sine it. Right, this is question 16 that I've got in front of me. Right?
Yeah.
So are you okay with those 4 lines, or is there a problem in those 4 lines?
My problem is after that line, but should we at 49 or should we multiply 49
Yes.
to the
Yes, we should have. Well caught. Because there's a 49 here, in which case there's going to be a 49 here. Yes,
it will be 49 over 2 sine
correct.
x.
You are
Okay.
right. I
Yeah.
just, I know.
Okay.
I'm just careless. I dropped it when I was doing my transfer.